Hello. I'm Eric. So I said I work in the AI group at National Bank of Canada in Montreal, as my accent doesn't say. And today I will present you a work we have conducted to answer, to try to tackle a very difficult problem, is to answer email automatically. I will explain why it's a very difficult problem. What is interesting in the work that I will presenting to you today is that first it's something that is in production currently. I will give you the number. And in some way, it's a very innovative technology because what we discovered is to handle emails, classical classification techniques that were used since now have difficulty to handle the diversity of the problem. And we used deep learning models used to classify the intentions of one of the bots we use at the bank to answer automatically to mails. And that's what is innovative, and I will show you how. So, in bank currently, many communication, exchange go through digital channels. So, digital channels, website, search engines, but there is still some needs for the customers to have exchange by phone calls or emails. And the particularity of those is that they are very expensive. Phone calls and emails, you need to have someone behind. And it's one of the last with operation, the last part of the financial organizations that can give a lot of advantage to be automated. For example, I give you some example. It's a wide range because I didn't want to give you the exact value at the bank, so I took on the internet some numbers, but it gives you a pretty good image. So phone calls that cost between $10 to $30. There is a variation because sometimes the length is different, the nature of the call is different, but that's the cost. You can imagine that with a few millions customers, you will have millions phone calls each year. So there is somewhere where there is a lot of room for productivity gains in an organization like ours. Email costs a lot, and it's not a good solution to remove the emails everywhere, like the major of the internet does, like eBay, for example, or Amazon. It's very difficult to send an email. But in fact, if you remove the emails, people will give a phone call, so it's more expensive than to have the email. It costs less, $10 to $15. And there is some solution on the market that are functional and widely adopted. Is the ones from Salesforce, for example, Einstein. But it's not a classification engine. When you use Einstein from Salesforce, for example, you send a mail, you have a list of potential suggestion of answers, and an agent has to select the good one. That means it's not automated. You still need an agent. You increase their productivity. It will cost now $5 to $8, but you need to have an agent. And it's not very interesting work because if you increase the productivity, it's very difficult to retain the people. It's a boring activity. So any solution to automate all of that, and I call that information access, you will see why, reduce operational cost and a big advantage. The customers, they have two categories of exchange that they want to see handled. The first category is informational. Informational it's the kind of question how to open an account. It's the question that can be solved by a UI. For example, how can I open an account? You can send someone to a form, can fill the form, open the account. How to activate my credit cards? It's an information. Most often you will have somewhere on the website where you can automatically, or on the app, where you can automatically activate your credit card. So this is very simple, in fact. It's a query that belongs to an answer that sent you to automated solutions. Transactional, it's much more difficult. Transactional is someone who have a credit card note and say, I don't understand, I don't know where it's come from. It's impossible with the actual state of the art in technology to manage that kind of case. There is another transactional kind of request is please make a money transfer. Of course, when you use, once again, an app, it's not transactional, it's very easy. You can fix it with a form, but there is still some people who want to have someone or do that through a mail. So those two categories, you will need to have different kind of organization and technology to handle those. The existing solutions to automate those exchange, it's a search engine, typically information retrieval, access to documentation, very old technology, began in the 60s. It works fine, but it's purely informational. Recommendation engine, a way to assist an agent to answer to something. Dialogue engines, bots. You have one on the right, we have 9 bots currently at National Bank in every activities that we have. Dialogue engines, when they are informational, it's very, very cool because you remove tons of calls. Question answering, it's another one. You can't let people go to FAQs and alone, they don't find anything, but if you have a good technology for question answering in a bot, in a search, it saves a lot of human operation. And classification is for the kind of activity like mails. It's asking, according to a document, can I find a class? And the class is the potential answer for this document. So here you have the help page of National Bank. Currently, you have no other solutions to provide the faculty for a user in a financial institution to send a message. You can't use the tricks that are used with tech companies. You have to give the possibility to send a message because sometimes there is very complex situation people want to deal with. They don't want to phone, and they need to have that. So when the user sends the message, for sure, it can go to a person. And this person, as I explained, with Salesforce, they will mostly, it's what is mostly used on the market, they will use the CRM and have a recommendation engines. And in this case, 100% of the messages are handled by a human. You increase productivity, but you don't save calls. What we suggested is, and it's interesting in many aspects, is can we put an automation in this process between the mail and the human? And if we could use a model to automatically try to answer to some of those messages, not necessarily all of the message, but some of those, we can reduce the workload on the call center. And if we find a way to put that in the middle between the mail sent and the CRM, we can handle just a part. We just need to solve completely the problem. And one of the issues with mail answering is you can't solve completely the problem. So what is the problem? The distribution first. 80% of mail requests are of informational nature, so that's good. That means it's the part of the problem that we can process with classification. 20% are transactional questions. That is not good, because if someone writes you a mail and say, I have a big issue, at the bank you have regulatory obligations to answer to this question and to give a lot of attention to this. So that means you can't make mistakes. You need to be sure that those 20% of transactional questions are properly handled. And the issue in the financial business is that with the classification system, you have a risk of error, and you are not allowed to have those errors. So that's one of the tricky aspects. Also the front tail is very easy to process. You will have 10%, 20% of message. They are always the same. Very easy to handle with classification. The long tail is very, very difficult to modelize because you have emails. So there is a virtually infinite way to say the same things with different words and different structure. So in the long tail, you can have thousands of messages completely different on the same topic. So it's very, very, very difficult to classify that. So if you try to solve the problem, if you take machine learning classification models, they are able to classify documents, no problem, but they make errors. And this is a regulatory problem for us. And they can provide a predefined class answer, so we can take the message, recognize it, and give the proper answer for this group of message. What ML models can't do, they do not know how to process transactions. So this 20%, we have to find a way to put it outside. They are not always good to handle multiple small classes. So when we have a message with a lot of samples, or few samples, but on the long tail, it will be difficult to tune the machine learning model. And we have difficulties to separate the long tail because of that. There is a lot of solution on the market. There is one on the screen. And I said it's a good example of something that is not working. We tried many applications. Usually, the vendors will tell you it works fine, no problem. In fact, all those problems and the specific regulatory problem, you will have them. It's not work. Graph generator, graph mining techniques, all that stuff. It's not working. It doesn't answer to your need. So, how to ensure that the customer receive a correct answer in that context? We have two aspects we can work on. The first one will be the model itself, or we can tune the model to make sure it answers to a acceptable subset of emails. And we will have to work on the user interface, because we can ask to the customer to help us to automate this process. So let's begin with the machine learning aspect. There is a lot of class. Hundreds, thousands of different questions. And the difficulties you see on the left, it's a tail that's made of the class we used at the bank. The biggest one, the first one, it's a transactional question. So the biggest class with the most amount of sample to train the model, in fact, is a transactional one that we don't want to answer with the machine learning model. In this case, it's I need information about the transaction. So as I said, the previous attempt had failed because of this question. Distribution mostly a long tail. Very few training sample for some questions. Classes are unbalanced, mostly unbalanced, and machine learning algorithm, even deep. We published papers 2 years ago about that. They don't like unbalanced classes, and you have a lot in that in these applications. Each answer is a class, of course. So it's not a model with just 3 or 4 classes that is easy to tune. It's a model with hundreds of classes, very difficult to tune. And of course, many questions with high frequency are highly transactional. So Difficulty will be if you tune your models, as usual, you will have very low F-score, a very bad precision, low recall, and you have the risk to have a lot of answers that are not the good answers, and back again at the regulation problem. So what we said, that we have a bot model. The bot model is answering to exactly the same kind of questions, but it's trained on little samples, just a phrase, a sentence, a few words. In our the most wide model we have, it covers 500 classes. There is a lot of intent with a very small amount of training samples. And what is interesting in the deep learning model that is in RASA, it returns for each question a probability that you have the good answer. And this probability is absolutely essential, this probability that is given by the deep models, because we will use it to configure our system. And here is it. You have the reference of the paper. At the bottom, it's published. It was published at Canadian AI. You have access to it and online. So what we see here, first we define that what you have on the left, the percentage of automated emails according to a very specific configuration. The part of the paper is on this question. The idea of those curves is you have some answers that are in scope, you have some answers that are out of scope, you have the accuracy of those categories. At some points, you can put a threshold on the answer for the machine learning model, where you can give the answers, because you will have a very high probability to have the good answer, and you will reject all the bad answers. What we say here is we don't try to answer to 50%, 70% of the emails. What we say is we are okay to try to answer to 15, 20% of the email, but we want those emails to be very good, to be the appropriate answer. And if we are not sure, let's do something else, and we will handle that with the UI. So that's the idea, and there is an algorithm that is published to find the maximizations of the good answers. That's what we had. This comes from an inspiration of the dead curves in the 90s for voice recognition system. It's not something that I've done previously. So the model profile that we have at the end, when the mail classifier should not answer, we have 90% of correct identification, meaning we have a very low probability. And that means we will have just 10% of cases where there is a risk to provide the bad answer. When the mail classifier should give an answer, 50% of cases, it gives an answer. And the 50% would stay, we don't give an answer. But it's okay, we just want to have good answer. And when the mail classifier gives an answer, it's good in 60% of cases. So we have our previous graph, we will find the threshold, and we will try to use those 60% of cases to have 95% of good answers with the correct threshold. At the end, in our first prototype, we were able to reduce the mail flow to 11%. So that's the spirit of this application. We don't want to handle 100% of the mails. Nobody knows how to do that. We want to reduce the flow, try to see how much emails we can handle automatically without any intervention of human and with no error. And it's 11%. It's enormous. It's 10% of the time on the call center who is on this task. So then we have the UI aspect, because we still have some errors, and we want to handle those errors. So the UI I don't know if there is competitor, you can take it. It's impossible to patent that. So if you want to use it on your own system, go on. The idea is the user will ask a question, as usual. It will send a mail. And then the classification model, if you remember the diagram at the beginning with the classifier in the middle, it will give an answer or not. If it doesn't give an answer, it will go on the normal flow and a human will answer. But in some configuration, the model gives an answer. Now, we want to be sure that we have the good answer. So the user read it, and he has the opportunity to validate. Is it the correct answer? Yes, no. And if the user is not OK with the answer, then the mail goes, as usual, to a human, and the human will make the answer. If it's accepted, if the user says, yes, it was the good answer, so it's finished. We say, OK, thank you, have a nice day. And we, in the other case, we didn't answer. An agent will answer rapidly to your question. In terms of user experience, it's wonderful, because usually, depending on the time of the year, people will have to wait 1 day, half a day, 2 days to have their answer. In 11% of cases, and when it's something that should be answered instantly, people have an instant answer. They are very, very happy. We save time, we increase the NPS. So it's a win-win. So just to conclude, it's a definitive solution. We don't train a new model. That's why it's very interesting. We reuse the existing bot models to train this. So it do not involve redesign of the existing systems. And you could say, oh, but you should do some training corpora using mails to increase the performance. No, we have a flow. We want to act on small aspect of the flow, optimize everything. If we have the same model for a big bot on this system, and it works fine, we have a lot of efficiency. It's very easy to integrate in the existing flow. Every people who work in big company knows that architecture is a nightmare, especially when you have legacy, and you have a lot of legacy in the financial industry. This one is very easy. You capture the question, you put your machine learning models, you have the UI, and then you continue the flow or not. It does not modify the behavior of existing tools. You have Salesforce, Remedy. You keep it the same. You don't have to retrain the people. You keep it the same. They just have less work and more time to work on difficult cases. It's very low cost. The same model is used for 2 important assets. And it's client-centric, as I said. Now we are at automatic answering in 13 to 17% of cases, meaning we can increase the performance of this system. The reduction of manual mail handling is by 12 to 15%. It's very good. And we have a relevance feedback, meaning when the user said yes or no, it's a good answer or not, we are able to refeed the model. And the customer answers, they can be used to improve the model. So that's the idea. Hope you find some interesting aspect. Thank you.